section 13.3, we are going to, eventually we'll evaluate the 6 trig functions, but the concept here is, what I'm going to draw this picture is very important, and this is how we connect rotational motion, where our angle starts at 0 degrees and we rotate counterclockwise. How do we connect rotational motion to rectangular motion, which is what we're used to, right, left, up, down? Connect rotational motion to rectangular motion. You know, rectangular motion is what you're used to when you have an ordered pair x, y. X tells you how far right or left, and y tells you how far up or down. But we want to connect this idea of rotating, this like rotating around a circle, to moving right, left, up, down. So this is the picture that does that. Okay, so we're going to draw a big circle. This is, remember when I draw, these are the kind of pictures that you're going to need to draw for your problems. This represents the XY axis, where we can move right, left, up, down, and then the circle represents rotational. So whenever you have an angle, like you're drawing an angle, the initial ray is always along the x-axis, the initial ray, and then we rotate a certain number of degrees around to, and this is the terminal side. So this picture, that is our rotation theta, is how we say the angle. And so, and you actually, when you rotate along the circle, you end up at this point xy. So watch now, I'm going to connect the rotation to the motion. What you do is you always drop a line down to the x-axis like this, and lo and behold, there is your right triangle. If you drop a line, it always goes down to the x-axis. You'll always be able to make a right angle with the x-axis, and therefore you have a right triangle. So the coordinate, this point right here on the circle xy, you move, in this case, you move to the right x and you move up y. Those are both positive if you move to the right x and up y. And this hypotenuse is the radius of the circle r. And this picture is just fundamental to the start of trig, of understanding this. So now we're going to define our trig functions. So looking at this picture, the sine of the angle, sine of theta, equals what? By looking at the picture, what over what? SOHCAHTOA. Sine is so. Opposite over hypotenuse, which is opposite side, is y. Hypotenuse is r. Good. Y over r. Yep. And then when we want to find the cosine of the angle, what's that ratio of what side lengths do we use? Adjacent, which is x, good, over, nice. And finally we have tangent is, TOA is, very good, opposite over adjacent. Y over x, yes. And then now I'm not going to write this here, but of course you have your reciprocal functions, which would just be the reciprocal of all these. And then there's one other special relationship that's super important when you solve trig equations, and it's very simple, and it's Pythagorean Theorem. So tell me, write the equation for Pythagorean Theorem using this picture. What is it? There, exactly. X squared plus y squared equals r squared. Okay, so being able to, draw that picture and do the ratios is key to the start of real trig. Now, so let's do some examples of what you'll be doing in just a second. Here's the test objective, right? It'll say evaluate the 6 trig functions. The 6 trig functions for theta. That's you'll see that in the list for the test objectives. So we're going to start with this example, number 1, and we're going to do two examples. And so all you're going to see when you're given a problem is the coordinate, -8, 15, and you're thinking, what? How am I supposed to evaluate trig functions? I don't see a triangle. I don't even know what that looks like. That's just a point, -8, 15. Well, you have to draw the picture. So in your assignment today, number 3 through 11, you have to draw the picture yourself. So let's do it. Here we are. It's not that bad. Here's the picture, and we'll use the same picture for all 6 trig functions. What quadrant? Here's your quadrants, 1, 2, 3, and 4. It goes counterclockwise, just like when we rotate around. Quadrant 1, 2, 3, 4. So which quadrant is -8, 15 in? It's quadrant 2. So what you do is, it doesn't have to be exact. You just put a point there, and that's the point, -8, 15. Right? You would go to the left 8 and up 15. But we need to make this rotation, so you're going to draw the angle that goes through it. Okay? So what we mean is this. We rotate from here to here. There's theta. Okay, so that's what your picture looks like, right? Connecting rotation to rectangular motion. Now here's the key, right? And write this in words too. Here, I'm going to write it here. It's so important. Here's the mistake. People try to make this right triangle by doing a horizontal line like this with the y-axis. No, no, no. That makes no sense. Don't do that. Okay? Here's the x-axis. Here's the y-axis. Always drop the line down to the x-axis, and your angle is formed with the x-axis for the right triangle, not this way. That makes no sense at all to have this right triangle over here. Go down, put your right angle there. So let's write for when you're reviewing for a test, form the right angle. Form right angle with the x-axis. Everything is relative to the x-axis, this axis right here. Okay, because that's where our angle starts too. It starts from here, from the x-axis, and then you rotate. Almost there. Now we need to label the sides of our triangle. Right here, here's the other common mistake. This side is -8 because you move to the left 8 and you move up 15. We're not saying the length of the side. We're talking about movement to the left and up. So it has to be -8 that side and up 15. And of course, what's this missing side? You're going to have to do Pythagorean Theorem, right, to find it. So this side is 7. It'll be 17. 8, 15, 17 is a Pythagorean triple. So you do -8 squared plus 15 squared equals c squared and solve for that. Should we show that, or are you okay with that? We're okay. Okay, we practiced that already. Okay. So now we get to just write our trig functions. So sine of the angle. Okay, we're going to do opposite over hypotenuse. So the opposite side, the angle you care about is this one, the one formed with the x-axis, this one. So it's going to be the opposite side is 15 over hypotenuse is 17. That's done. That's the sine of the angle. The cosine of the angle is, what's adjacent? Negative. Cosine is negative in that quadrant. -8 over 17. Tangent is opposite over. Yeah, and now do me a favor. It's kind of bad form to put a negative in the bottom. Just put it on the top. Even though it's 15 over -8, it's still, the whole fraction is negative, so you should put it on the top. So that's done. Now we do cosecant, which goes along with sine. Reciprocal is, yep, when you do your reciprocal functions, you don't even need to look at the original picture. You don't even need to think that hard about it. It's just the reciprocal. What's the reciprocal of -8 over 17? -17 over 8. The sign stays the same. All reciprocal means is flip. Cotangent is and so that's one complete example. I want to do one more example on the next board, so be sure you have that. I'm going to go to the next one. So example 2 is the point, let's see, I want to evaluate all 6 trig functions for the point -5, -12. Okay, and then we'll practice. You'll practice. We are practicing now. Okay, so which quadrant? Let's practice. Okay, so tell me which quadrant the point -5, -12 is in. Good, the third. 1, 2, 3. Because I have to go to the left and down. So if I were to plot a point on the xy axis with rectangular motion, that's -5, -12. So that's the start. Now we need to draw an angle that rotates. We always start at 0 degrees and rotate around. So you need 2 rays to indicate rotational. To draw an angle, you need 2 rays. So put those in. Start here, rotate around. So that's theta. You're rotating around. And now you have to make that, you need a right triangle, otherwise you won't know where sine, cosine, and tangent are. Always drop from the point to down to the x, or up in this case, to the x-axis. There's your right triangle. Okay, so save yourself. Now let's label the sides. I'm just going to move the symbol. Label them to get to this point. You would move to the left 5 and down 12, so those need to be negative and negative. And if you memorize your Pythagorean triple, 5, 12, what number goes here? 13. So you either memorize them, or you would say a squared plus b squared equals c squared. And now we're ready. Once you have the picture right, the rest is much easier. So sine of theta is, you guys tell me. Sine of the angle is? Remember, you're looking right here, the angle that's formed with the x-axis. So relative to this, yes, -12 over 13. Cosine of theta is, I heard -5 over 13. Maybe that's what I wanted to hear. Tangent is? Which simplifies to 12 over 5, yes, because they're both negative. So the tangent is positive in quadrant 3, always. Do you see that you can tell the tangent will always be positive in quadrant 3, because it'll always be negative, negative to move to that quadrant? Okay, so let's finish. Cosecant is reciprocal. Good. Secant, because it takes a second to go to Costco. Costco is, yeah, and cotangent, very good. This needs to, we need to practice this first, and then we can talk about, what I'm going to talk about next is, what if the angle lies on one of the quadrants? Like, what if theta is a 0 degree angle or a 90 degree angle? Do you see how, or a 180 or 270? You wouldn't form a right triangle at all, so what do we do? That's what I'm going to talk about next.